Now we are discussing about VI characteristics of the thyristor. You might have studied the VI characteristics of the diode and VI characteristics of the transistor, input and output characteristics. Now we are discussing the VI characteristics of thyristor, which is also called as silicon control rectifier or SCR. It is a 4-layer device and 3-terminal device, 3 junctions device. So thyristor is having how many layers? 4 layers. How many terminals? The 3 terminals are anode, cathode, gate. It is having 3 junctions. The 3 junctions are J1, J2, J3. Initially, we are giving the positive voltage to the anode with respect to the cathode. So anode voltage is higher with respect to the cathode. And we have kept this switch S is open. Means we are not giving any gate current. So Iz equal to 0. Because the anode voltage is positive and cathode is negative, junction J1 is forward biased. Junction J3 is forward biased because at the p-type layer the voltage is positive for the both J1 and J3 junctions. For J2 junction at N region there is a positive voltage, that's why it is reverse biased. So it appears like this is on, but this is off. Because of this junction J2, the thyristor is in off state. If this junction would have on, then the thyristor is in on state. Because the junction J2 is blocking to on the SCR, it is called as forward blocking. It is off state, but still we are giving the reason. Forward blocking. Who is blocking? Junction J2 is blocking. Still the thyristor is in off state. But still there is a small current observed that is in the range of the milliamperes. This current is constant. Even though we are increasing the anode voltage, the current is constant. We are increasing. At a certain point, that is called as breakover voltage. Suddenly, the junction J2, which is in reverse bias, it breaks down. The reverse breakdown can be occurred due to 2 phenomena we have already discussed. One may be Zener breakdown. In order to occur the Zener breakdown, the PN N region should be heavily doped. But here they are not heavily doped. There is another breakdown which is called as avalanche breakdown. Even though the P and N regions are not heavily doped, avalanche breakdown will occur due to the collision. If the breakdown occurs due to the electrostatic field, that is called as Zener breakdown. If the breakdown occurs due to the collision, then it is called as avalanche breakdown. Because of the avalanche breakdown, J2 gets breakdown and the thyristor is in on state. When it is on, anode and cathode terminals are short. What is the voltage difference? Practically we will discuss later, but theoretically it should be 0. Because of the internal resistance, there might be 1 to 1.5 volts. So this voltage, breakover voltage, after the occurrence of the breakover voltage, suddenly the voltage drops from VBO to 1 volt. Sir, how much value is breakover voltage? For the thyristor, minimum breakover voltage is 200 volts. It is in the range of 200 to 600 volts. So practically we require minimum 200 volts to turn on this thyristor. That is not AC, this is pure DC. So after we give 200 volts, Suddenly the thyristor turns on and the voltage between the anode and cathode drops to 1 volt. So it is not dropping from 200, suddenly it is 200 to 199, it is dropping from 200 to 1 volt. That's why we have shown that drop with the dashed line. Now the voltage is 1 volt or 1.5. If we are increasing the anode voltage still, the voltage will not increase, that is remaining same. Even though the increment is there, that is a negligible amount of increment compared to the increment we are giving at the anode terminal. But the increment which we are observing very sharply is the anode current. When we are increasing the voltage after the breakover voltage, still at that time the anode current is rising. This current cannot be controlled by us. So we require an external load to control this anode current. By using this external load, we can control the anode current. We can reduce the anode current. When we are reducing this anode current, if we reduce the anode current below some point, thyristor will turn off. So what is the minimum anode current required to maintain the thyristor on is called as latching current. After this current, the thyristor will be on state continuously. So if you want to turn off the thyristor, then you have to bring the anode current to below the holding current. It is like your latching current is your pass mark 28, your holding current is fail mark 27. Example, if we get the 28, your pass, the thyristor is on. 29, your pass, thyristor is on. So above the latching current, if we maintain, the thyristor will be in the on state only. 27, fail. Example 26, 25, 0, fail. So holding current off, below the holding current off. The difference between this latching and holding is very small. So this anode current is rising sharply. That can be controlled by using the external load. This is when the thyristor is in on state, then only this rise will happen. But we cannot control this rise without load. So we are controlling by using the external impedance. Now in the second case, when we give the positive voltage to the cathode, then what happens? J1 will be reverse bias because anode is negative and J3 is reverse biased. But J2 is forward biased. Still it is in off state. But this is called as reverse blocking. Previous one we called as forward blocking. Now we are calling this as reverse blocking. If we increase the cathode voltage further, J1 will break down, J3 will break down, then thyristor will get damaged. So we should never increase the reverse voltage. We should never give the voltage to the cathode until the reverse breakover voltage. We never operate thyristor in this region. Thyristor is an unidirectional device. We always operate the thyristor in this region because it is an unidirectional device. Sir, you have discussed thyristors initially, it will give milliamperes. Now in this region, you are showing current that is very small. It is in the range of the microamperes. That's why we are not using. Okay, what is the use of this gate terminal? Until now you have discussed anode and cathode. Why suddenly you have brought the another terminal, third terminal, when the gate current is 0? Practically, it is difficult to give 200 volts to turn on the thyristor. So, by giving some gate current, the thyristor will turn on before the breakover voltage. A small gate current in the range of the milliamperes can turn on the thyristor before 200 volts. Sir, I want to turn it on for 100 volts. Yes, give gate current IG1. I want to turn it on for the 30 volts. Yes, give some gate current IG2. So you can turn on at the practical our RPS voltages. The thyristor can be turned on, but by providing the gate current. But if we remove, once the thyristor is on, if we remove the gate current, then the thyristor will not turn off. We require an external load to turn off the thyristor. These are the VI characteristics of thyristor. Thyristor is having how many layers? How many terminals? How many junctions? What are the three terminals? What are the three junctions? Okay, initially we have given positive to the anode, negative to the cathode. Means anode voltage is more compared to the cathode. At that time, which junctions are forward biased? Which is reverse biased? Okay, now if we are increasing voltage more, which junction will get breakdown? Due to what factor it will break down? Avalanche breakdown. Now the thyristor is in, so its voltage will drop from breakover voltage to 1 to 1.5. By using which factor we can turn on the thyristor before the breakover voltage? Gate current. The more we increase the gate current, at lesser voltages we can turn on the thyristor. Okay, once the thyristor is turned on, its anode current rises sharply. How can we control it? External load. By using the external load, if we are reducing the current, what is the minimum current to maintain the thyristor in on state? If we decrease the below which current, the thyristor will turn off? Okay. Can we operate the thyristor in the third quadrant? We can operate in the, whether it is unidirectional device or bidirectional device. If we give the positive voltage to the cathode with respect to anode, which junctions are forward biased? Only J2. Which are reverse biased? If we increase more voltage, which junctions will break down? It will damage the thyristor.